front.
Excuse me, sir. This was my mistake.
Okay, so who was it?
Sir, I am Abu Jawad Mohammad Ridwan Hossain.
Okay, thanks. So I will speak with you later. But since you accepted it, that's good. The section will be spared. Okay. Okay. So we will go to today's topic directly. Well done, Abu Jawad. Okay, let us begin our topics for today. So, if we recap previous class, in our previous class, what we have learned about are basic operators and expressions. What are expressions? What are operators? And we have learned about basic arithmetic operators like unary plus, unary minus, the multiplicative operators, and the additive operators. Did anyone raise their hand? And multiplicative and additive operators. And we also learned about the precedence and the associativity operators. And we also learned that if we know about the precedence, the associativity, and how an operator behave, and what are the operands, and what are the types of the operands, in that case, we can evaluate the result. Anyways, so let's move on to today's topic. In today's topic is mainly about assignment operators and different kind of assignment operators, and then increment and decrement operators. So the simplest form of assignment operator in C is V is equal to E. This equal sign is the simplest assignment operator, where V is the value and E is the expression. So the value and expression. The simplest operator can be like this, like I is equal to 10, where the value 10 is directly being stored in the variable I, or it can also be a large expression that can be evaluated. The expression can even be larger than this one. It can be evaluated, and then the value that is evaluated is stored in the variable J. This is the expression, this is the variable. So what will happen if the variable and the expression are not of the same type? Like if we want to, here I is an integer, and f is a float. If you want to store the floating point value 72.99 in the integer I, what will happen? First, this one will be converted to an integer. And we know when float is directly converted to an integer, it is truncated, not rounded up. So as a result, 72 will be stored in I. Similarly, if we want to store the integer value 10 inside the floating point variable f, what will happen? 10 will actually become a floating point variable first, floating point number first, and then it will be stored in f. Okay. So, yeah, unlike many other languages, in C, operators or assignment is actually an expression. It's not just a statement. And as we know, any expression can be evaluated. So, if you write something like this, I is equal to 10, this is actually an expression, and it can be evaluated to a value like 10. Okay. So, as a result, we can use assignment themselves as sub-expressions. That means part of another expression, and we can also chain together assignments. So let us see some example. First, I've declared three integers, I, j, and k. And I can write I is equal to j into k equal to k is equal to j. And if that happens, I can, if I print the value of I, j, and k, compile it. Can anybody guess what will be the value of I, j, and k? Anyone? So all of their values will be 10.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, all of their values are 10. All of their values are actually 10. So in the similar way, remember, when I write something like this, I is equal to 10, this thing is evaluated to 10 as well. After storing the value 10 to I, whatever was stored will be returned. If I is an integer, 10 will be returned. So what if I write something like this? I is equal to, j is equal to 10 plus a is equal to 5. Can anyone tell me what are the values of I, j and k after the evaluation of the expression, of this expression?
Sir,
What?
15, 10 and 5.
I is equal to
15 and
15, j is equal to 10,
10.
k is equal to 5, right? Let's see whether it matters or not. Yes, it is correct. So did all of you understand how this thing was assigned and evaluated?
Yes, sir.
Yes, sir.
Yes, sir.
See, they can be chained together and they can be part of sub expression as well. So remember, assignment operators are right associative instead of like left association or being grouped from left to right. Assignment operators are always grouped from right to left, and they have least precedence. Among all the operators that we have seen, they have the least precedence, not just simplest assignment, any kind of assignment operator. All of these are assignment operators. There are even more. So all of these have the least precedence among the things that we have seen so far, and they are right associative. So yeah, since they are right associative, or by saying that they are right associative is something like this. If I undo, how this statement is evaluated is like this. First, the rightmost assignment is grouped together, and the one before that. This thing is completely similar to the previous one. Okay, this is how the compiler groups them together. Now you need to be careful about the types of the variable where you are storing the data. So if we take a look at this, write float f, and if I write f is equal to I is equal to, let's say, 51.25, I want to print the value of I and f. It should be %f. Okay, can anybody guess what are the values of I and f?
So 51 and 51.1.
51 and 51.0.
Okay, so first of all, what can be the value of f? Again,
So float.
51.00.
51.00.
okay, is there anyone who's saying 51.25?
Oh, sir, it's 51.
All of you are saying like it's like 51, and all of you are saying 50, I is 51, and it is correct. So the value 51.25 will be first assigned to the integer I. Now if I assign the value 51.25 to the integer I will become 51, and this whole thing will be evaluated after storing the value 51 in I. The whole thing will be evaluated as just 51, and after you try to store 51 in the floating point variable f, it will become 51.0. Take a look at this. It's 51 and then 51.00. So now let us talk about side effects. When we deal
Sir,
with
I had a question, sir.
Yes,
If
sure.
we gave the line as I equal to f equal to 51.25, then the result would be 51.25 and 51, right?
yes, correct. Since 51.25 is being assigned directly to the float will have the value 51.25, and now this one will be evaluated with as 51.25 or 51.25f to be more precise, whatever. So 51.25, and then it will be stored in I. Since I is an integer, it will be converted to integer, and it will become just 51.
Understood. Thank you, sir.
Sir?
Yes.
In the first case, shouldn't the answer of shouldn't the value of f be 51.60?
Why? How did you get the 60 part here? right?
So by default, or I think I'm mistaking, or
The compiler doesn't change any number, okay, unless you ask it to. The only thing that happens when you convert a floating point to integer directly, it gets truncated, and getting truncated means it just removes the fractional part. It keeps the integral part, but it removes the fractional part. Okay,
okay, sir.
that's what happens. Values will never change, because if these kind of things happen, programming would be really difficult. Okay.
Yes.
So let's talk about side effect now. So when we deal with most of the operators, like the assignment operators, I can write like this integer I is equal to 10, j is equal to 20. If I write a blank statement just like this, I plus j, I can also print it out, right? But if I write a blank statement like this, so what will be the evaluation of this expression, I plus j? 30, right? Simply 30. Simply 30. But has this plus operator changed the value of I or j?
No, sir.
No, sir.
They haven't. They simply produced a new value that is 30, right? Without modifying the values of I and j. However, if I write something like this, I is equal to 5. This operator, plus operator, doesn't change the value of j. However, this assignment operator does change the value of I, right? Now j plus 5, that is 25, is being assigned to I, right? In this expression.
Yes, sir.
So,
Yes, sir.
so the assignment operator is actually modifying the value of I, right?
Yes, sir. Yes, sir.
Yes, sir.
In all those cases, or all those operators that actually modify the value of one or more of its operand are called operators with side effects. So the simple assignment operator is one of the operators with side effects, like integer I, integer j. This one doesn't have side effect, but I is equal to j is equal to 5. This one will be evaluated first, and then this whole thing. This here, the assignment operator has side effect. Moving on. So I will not discuss much into what are L values, because they are a quite complex topic, and you will learn about them most probably at the end of 4th year. But for now, think of L values as just variables. So what it says that whenever you're performing any kind of assignment, the left hand side of that assignment must be a variable. So somebody asked, I don't know whether it was from this section or not. So but the left side of the assignment must be a variable. So this is not actually allowed. Why? Because if I write something like this, I plus j equal to 20, what is all like 30? What is happening? I'm trying to store, plus has more precedence than the equal operator, right? Or the assignment operator. So this one will be evaluated first. Now what I am trying to evaluate my expression is as 30 is equal to 30 is equal to 30. So I am trying to assign the value 30 to the other value 30, which is not actually acceptable. The assignment operator must have a variable. I mean, this I can make it even 50. And then we'll be trying to assign the value 50 to another numeric value, numeric constant 30, which is actually incorrect. So the left hand side of the assignment operator must be a valid L value, or like a valid variable. Okay, so think of them as just variables for now. So similarly, you saw that if I declare another integer k, then I write k is equal to I is equal to 20, or I is equal to, let's say, 5, plus j is equal to 10. If I do it like this, so what's happening? I have put the brackets here, right? But what will happen if I do not put the bracket here? The previous one, this one that I'm cutting, the one with the brackets will work. But this one will not work. Can you tell me why? Anyone?
Because plus has more precedence than equal.
Exactly. Because plus has more precedence than equal. So this one will be evaluated first. And now this is just plain j plus 5 is equal to 25, and I'm trying to assign something like this, which is not correct. So this statement will not work. So moving on. The compound assignment. About compound assignment, let's say there are 50 students in my class, right now, and 2 more students join. So what I can write to update the value, I is equal to I plus 2, right? After that, 3 more students join, and I can write I is equal to I plus 3. So what is happening? This is 50. This is being evaluated as 50 plus 2, 50 plus 2, which is producing 52, and this is being evaluated as 50 plus 3, and which is producing the value
50 plus 3 or 53 plus 3?
Sir, 53 plus
53 plus 3, which is producing the value.
Sir, 52 plus 3.
Yeah,
52 plus 3.
Sir, 52 plus 3.
52 plus 3, which is 55. So we can actually simplify these statements. C provides us with a simplified operator for the similar statement, which is plus equal to. I can, instead of writing these 2 lines, I can write them as I plus equal to 2 and I plus equal to 3. So what is happening? This statement is equivalent to I is equal to I plus 2. That means I'm incrementing the value of I by 2. Whatever the existing value of I is, increase it by 2, and whatever the existing value of I, increase it by 3. These are called compound assignment operators, and this is the plus equal to. So yeah, this is the plus equal to. I'll become 3. Similarly, we have other compound assignment operators. Plus equal to, like minus equal to v is equal to v minus e, multiply equal to v is equal to v into e, divide equal to v divided by e, v is equal to v divided by e, and then mod equal to, or percentage is equal to, whatever you want to call, or remainder equal to v is equal to v mod of e, or remainder of e. Remember one thing, yes?
What is the benefit of using this type of assignment?
This is shorter than that one.
Oh,
Okay, this is shorter than that one, and also this one behaves a bit differently. You'll be writing this a lot, and remember one thing: the equal to assignment operator and the plus equal to operator. These are not expanded as this. This operator is directly processed, and the value of I is incremented by 5. All of them, all of the assignment operators, the normal simple assignment with the equal symbol, and all of these 5 have the same amount of precedence. So if I write something like this, j is equal to I plus equal to 2, or maybe j is equal to I have another variable, let's say k plus equal to 2, what will happen? All of them have same precedence, and they are evaluated from right to left, right associative. So this one will be evaluated first, and it will be evaluated as 7, and k will become 7, and then this one will be evaluated, I plus equal to 7, and I will become 57, and then j is equal to 57, so the value 57, this is not plus equal to, this is just simple assignment. So j will simply become 57 after this one. So yeah, they are directly evaluated from right to left. Okay, let's move on. So there's an even shorter form. So we can increment the value by any amount if we need. However, the most common one that we will do, let's say you have a system that is on a continuous observation when students are entering, and whenever a new student enters, the value of the existing student in the class increases by 1. So we can write it like I plus plus. It is equivalent to I is equal to I plus equal to 1. Sorry, I is equal to I plus 1, or we can write it similar to I plus equal to 1. However, they evaluated a bit differently. It simply means whatever the value, existing value of I is, increase it by 1 and then store it back in I. So I plus plus means I was 50 before, and after executing this statement or expression, I will become 51. This is an unary operator, so it only requires one operand, and it works on that. So similarly, we also have I minus minus, which means whatever the existing value of I is, in this case, the existing value of I was first, initially it was 50, then it became 51, and now it will become 50 again. So these are the only two types of increment and decrements we have. We can increase it or decrease it. However, there are two variations among them. So these are the increment and decrement operators. So they can work with integer or float or any data type that are numbers, actually numerical. So there are two versions. One is called postfix, another is called prefix. Now these are a bit tricky and sometimes they can cause some problems, and that's why many of the programming languages do not have them. Like Python do not have direct increment or decrement operators. However, in C we have them. So let's take a look at these two examples. So in this example, I is equal to 1, I plus plus is written directly inside the printf statement, and then the value of I is printed again. This plus plus that comes after I is called postfix increment. What it does, the compiler plays a trick here. When this whole statement is executed, first compiler says that, okay, I need to increment I, but the compiler doesn't immediately increase the value of I. The existing value of I is passed inside this printf statement. The printf prints I is equal to 1, and after the execution of this statement is over, somewhere between this statement and this statement, the value of I is increased by 1, and whenever you try to print I next, it will become 2. However, if you are using the prefix increment, which is placed before the variable, like plus plus I, what will happen? The value of I will be incremented first. Somewhere between the assignment, this statement and this statement, I will be increased first to the value of 2, and then 2 will be printed. And if you call it again, it will still print 2. So if I want to give you an example, let's say integer I is equal to 1, I write it like this. Integer A is equal to B plus I plus plus. Remember, the plus plus and the increment and the decrement operators have the highest precedence. The postfix increment, the one that comes after, has the highest precedence, and they are left associative. They are mainly left associative so that they take the left operand. And the prefix increment and decrement operators are actually right associative, and they have second highest precedence. So in this case, I plus plus will be evaluated first. This is completely same. Now, we print the value of I and j. Enter 0. So can anybody guess what will be the value of I and j after the execution of this program?
Sir, I will be 2 and J will be 4.
I think the result will be 5.
So
I will
J
be
will
2.
be J will be 4.
Okay.
J will be
J will be
5.
4 or 5. Okay. So so how many are in favor of 4? Say yes in the microphone by unmuting yourself.
4, sir.
So 4.
4. And how many are in favor of 5?
5, sir.
5.
Sir, 5.
5, sir.
Did someone raise their hand or something? Anyways. Yes, Tanvi Tanmoy.
5, sir, I wanted to say.
Okay, you don't need to raise your hand, you can just speak. Okay, just speak. When I tell you to speak, you can just speak. Okay, anyways, so some of you are saying that it is 4 and some of you are saying that it is 5. So let's see what is the actual value, what are the actual values. So yeah, it is 5, I is 2. However, the value of j is 4. Why? Because this is the post increment. So when this evaluation and this expression is evaluated, first the compiler processes this I plus plus in the very beginning. It is fine. So the compiler takes a note that I need to increase the value of I, but for now I will use the value 1. Yes, anyone who wants to ask a question? So for now the value 1 is directly used. 3 plus 1 is 4, and after this expression is evaluated, now the value of I is actually incremented by 1 and I becomes 2. That's why it happens like this. However, if I have written it like this, plus plus I, and can anybody tell me what will be the output of this program, or what are the evaluated values?
So now it's 2 and 5.
Yes. Now it will be 2 and 5. Okay. Because before evaluating this expression, the value of I is actually increasing, and then 3 and 2 are being added together, and the result is 5. So remember, people, that's why sometimes this can create confusion and people do not use them directly inside expressions. The most common version that you will see is something like this: I plus plus as a single statement, or like maybe minus minus I as a single statement, or I minus minus, or plus plus I. Those things as a single separate statement. It keeps the code clean and it helps you to understand better. Okay. So yeah, similar applies for decremental part as well. Finally, let us take a look at expression evaluation. Now, since we have looked at all the things, we can try to evaluate statements. And what we need are the precedence, associativity, and the operand types and the behavior of the operator. So let's try to group this statement in the way the compiler will process them. Now, if we go to, let's write it just here. Okay. For now, ignore the red squiggles. Okay. In this way, you can see the brackets being colored together and it will be helpful for you. So let's take a look at table 2. According to table 2, which operators have the highest precedence? The postfix, increment, and decrement operators, right? So we need to deal with them first. So let us take a look at our example. Do we have any postfix, increment, or decrement operator? Which we need to do first?
C++.
Yes.
C++.
So C++ will be processed first. Next, which one has the next highest precedence?
Increment prefix.
Decrement, increment, decrement prefix, and also unary plus minus. They have the same precedence, right? And all of them are right associative. So we need to process them first, okay? Okay. So there we go. This is a pre-decrement. This is a unary minus. And do we have any more unary minus or pre-decrement operator or something like this for increment or unary plus? No, right?
Minus D.
No, sir.
No, that is a binary minus, arithmetic minus. That's not unary, right? Because it has a left operand and it has a right operand. That's why it's a binary minus, not a unary one. Okay. So the next one that we need to deal with are the multiplicative arithmetic operators: multiplication, division, and modulus or remainder, and they are left associative. So we need to group them from left to right. So we have then this one, right? The division. It has more precedence than binary plus or minus. These are additive, these are multiplicative. So we group these together first. Okay. So these things we group together now. And now we need to deal with the binary plus and minus, the additive arithmetic operators, and they are associated from left to right, right? So tell me, which one will be grouped first? This part, the C++ minus D, or D plus this part? Which one will be evaluated first, the first one or the second one?
First one. So the first one.
Yes, the first one. Yes, the first one will be evaluated first since they are left associative. So this one will be evaluated first, and after that, this one will be evaluated. So now we have only two more operators left with the lowest precedence, the equal to and plus equal to. And equal to and plus equal to have the same amount of precedence, right? And they are right associative. So tell me, which one will be grouped first? This one, the first one, or the second one?
So the second one.
Yes, the second one will be grouped first. And this is how the whole statement will be evaluated by the compiler. If we want to change the natural ordering, then we need to put the brackets or someplace else, but this is the natural ordering of the compiler. Okay. So this is how expressions are implemented. Now finally, the last topics for today, a couple of notes. First of all, self-expression evaluation. So we can write an expression like this, right? I is equal to I into 2 plus I divided by 2. That's fine. We know that multiplication and division has higher precedence than addition operator. So they will be evaluated first. But can you tell me, among these two, I into 2 and I divided by 2, which one will be evaluated first by the compiler, I into 2 or I divided by 2, though it will not change the results.
I
Sir,
into
they,
I divided by 2.
Multiplication will be done previously, sir, because it is at first.
Okay, so we cannot actually tell which one will be done first. So these are called sub-expressions, right? And whichever way they are evaluated generally does not change the result, but there are some cases where it will change the result. However, in these kind of sub-expressions, it is actually completely dependent on how the compiler is designed. So you don't need to understand or remember what are the next things that I will say. So when designing compiler has something called a step called parsing, where it actually reads the statement and tries to proper evaluation for it. And there are different types of parser, and depending on the type of parser that is implemented on that compiler, it might be read from right to left. The sub-expressions might be evaluated from right to left, or they might be evaluated from left to right, or there might be a mix of those. So anyways, there's no way that we can tell, unless we know about the compiler completely, that which statement will be evaluated first. So though in this case, this will not create any problem, there are cases like I into I++. Now, this statement has some problem. It might change the result. Why? We know that the value of I++, this is a post increment, right? So the value of I++ for now will be evaluated as 2. This is completely fine. And after the execution of this statement, I will become 3. However, is this statement evaluated, sub-expression evaluated first, or if this one evaluated first? Because if this one is evaluated first, what happens? This is 2, and this is 2 plus plus. That means 2 into 2 is equal to 4. So j is 4, and then I becomes 3. Or if this statement is evaluated first, I++. For now, this is 2. This is evaluated as 2. Now I increments by 1, I becomes 3. This becomes 3. 3 into 2 is 6. So value of j can either be 4 or 6 depending on the implementation of the compiler. So these create undefined behavior. In short, what you need to learn from these statements is never write these kind of statements that cannot be determined. And I personally would recommend, do not try to write like I++, I minus minus, or minus minus I plus I inside another expression. Keep them separate for your own purpose, and do not try to do like changed assignment if they are very complex, like I is equal to j is equal to k is equal to 10. That is fine. However, if you want to write j is equal to I is equal to 5 plus k plus equal to 6, those looks bad, like things like that. Like this.
Sir, I had a question here, sir.
Sure.
In the last slide, sir, if I, sir, there post increment, sir, there is I++. We have used, if we used brackets, sir, then won't it be done for individually at first?
No. If you give the brackets, whether you give the brackets or not, the natural evolution is like this. That means here, this is a group together, and I++ is the second one. So these are sub-expressions, not that it will be completely evaluated first. No. It does the sub-expression, how the things inside a bracket are evaluated, in which order, the compiler does not care about that. Okay. So there's no way you can import. If you really want to do this first, you need to write it as a separate statement before this statement. Okay.
Yes, sir.
Otherwise, it won't be evaluated first. You need to write it like I++, then j is equal to I into I, if you really want to implement in that way. So there are always bypasses to avoid this type of situations, and do use those bypasses. Okay. So finally, the last topic, that is expression statement. So any C expression can be used as a statement, like this one, I is equal to 10. This is fine. I++. This is also, all of these are fine as statements. However, I is equal to 10. This is a useful statement. Why? We are storing the value 10 inside the variable I, and we can use it later. I++, we are incrementing the existing value of I by 1. It becomes 11, and we can still use it. I plus is equal to 2. We are incrementing it by 2 again, and it will now become 13, and we can still use it. However, if I write something like this, I is equal to I plus 50, and we do not assign it to somewhere, and we are not using it in any way, the compiler will evaluate it as 63, but can it be used in any place unless we assign it or print it? No, right?
Sir, I have a question.
Also,
Yes.
Sir, in the previous slide, can you go there? So if we evaluate I plus plus, then I becomes 3, right? Then
Yes.
3 into 3 should be 9, or why is it
No.
6?
If it is I plus plus, if we evaluate
Okay.
it, I becomes 3, but the value it leaves here is 2. See, this is why this is post increment. If you write it
Oh.
like plus plus I, it will be 3 here as well. Okay. So each sub expression can be evaluated as another value, right? A numerical
Yes, sir.
value. So I plus plus, if you write this one, I will become 3, but this expression will be evaluated as 2.
I see. Yes,
So
sir.
then, but now the problem is whether this one was evaluated to number first or whether this one. If this one was evaluated first, it was still 2, right? And then
Yes,
2
sir.
into 2 becomes 4. However, if this one was evaluated first, then what would happen? The value here will be 2, but next time when this I is evaluated, it will be 3, right? So
Okay.
2
Yes,
into
sir.
3, it will become 6.
Yes, sir.
Sir,
So, yes.
sir, in the previous slide, I just couldn't relate j is equal to I into I plus plus, which turns to 4. Actually, how the result 4 has
Okay.
come. I just
So-
thought it 5.
Okay, let's see. Let's say I is 1 and j is some other kind of variable. And I am to assign it like this. J is equal to 5 plus I plus plus. Let's work with this one plus first. What will the value of I and what will be the value of j? If I print this one.
Sir,
I will be 2,
One
J
in
will
six.
be 3.
Okay, are you fine with the value of j being 6? Now, who was asking me questions?
sir, I thought that the value of j will be 7 because I has been incremented first and then
So-
the value of I incremented I is added with 5.
Whatever. So in these cases, I is not actually incremented first. That's why it's called post increment. Remember, the post fixed increment. Post means later. What happens when we're evaluating I plus plus? When we're evaluating value I plus plus, the compiler takes a note that I need to increase the value of I, but not now. What happens instead of I plus plus, the compiler puts the value 1 here and then increase the value of I. Remember, each statement can be evaluated as each expression can be evaluated. Like if I write I is equal to 10, this can be evaluated as just 10, right?
Yes, sir.
However, if I write I plus plus, this and if the previous value of I is 1, let's ignore this one for now. This statement I plus plus here, I first will be this expression will be evaluated as 1. However, after this statement is executed, the value of I will be 2. That's how the compiler is designed. The evaluation of this expression is 1. However, the value of I will become 2.
Okay, sir, I've got it. That means after the execution, the value of I will be 2.
Yes. But this expression will be evaluated as 1. Okay?
Yes, sir. I will. Thank you.
That's why when we write something like this, a is equal to I plus I plus plus. So there can be two conditions, right? If I put the brackets here, since we do not know the order of sub-expression evaluation, either this I will be converted to numerical value or evaluated first, and then this one will be evaluated, or this one will be evaluated first, and then this one will be evaluated. Let us check at the first case. If this I is evaluated first, what is the value of I?
So 1.
1, right? Plus, then I plus plus will be executed. What will be the evaluation value of I plus plus?
2.
No, the evaluation
One.
value of I plus plus is
I plus-
1. However, I will become 2. Okay, after the execution. So in this case, the value of j will become 2. Right? However, if this I plus plus is evaluated first, let's put a question mark here for now. And if this I plus plus is evaluated first, what will be the evaluation of this statement? 1. It is still 1. However, now the value of I has incremented, right?
Yes, sir.
Yes, sir.
And what will be the evaluation of this statement?
2 plus 1.
Yeah. This will now be 2, and that's why it will become 2 plus 1 equal to 3, and I is 2. Got it?
Yes,
Yes,
sir.
sir.
Got it.
Yes.
Thank you, sir.
Thank you, sir.
So anyways, so I was saying that this type of statement, I plus 50, we are not storing it anywhere, right? We are not using it in any way. We're not doing anything with it. So whether we write this line in our code or not, and plus is not an operator with side effect, whether we write this line in our code or not, will the overall output or outcome change?
No, sir.
Right. So it will change nothing. So basically, this is just a stress statement in my whole code that is doing absolutely nothing. The compiler will still compile it fine. It will be evaluated to just 63, but then the value will be discarded, right? We're not using that value. So this type of statements are not error, but they are useless. So you do not need to write these kind of things. Why it can happen? So if you look at your keyboard, generally the plus and equal to symbols are on the same key. So if I mistakenly hold shift while pressing the equal key, I will write something I is equal to I plus 50 instead of writing I equal to 50. And since this is not wrong, my linter or the runtime system that actually points out my mistake will not point out any mistake. I might write this, and due to this, my program might produce wrong result, and I will not know why that thing is happening, and then I need to check back everything to find out what are the problems. So that's why be careful when you write some statements like this. Okay. That's all. Any question from today's class? Okay. If there is no question, I will show you one thing. You can take a look here, and this one will give you a large list of operators. These are the precedence of all the operators that are in C. You do not need to remember all of those, but whenever we cover more operators, more data types, and we might encounter some more operators. And from there, from here, you can look at their precedence and their associativity, so that you can evaluate expressions containing those operators. Like this will be the very common ones we use afterwards. Okay. And that's all for today. So we can. Yes.
Sir, I wanted to say something on behalf of our class. Actually, sir, whatever happened today, we are really sorry and we are really embarrassed.
It's fine. You don't worry. You do not need to say, or any of you do not need to say sorry on behalf of your class. The person who did it actually accepted that he is guilty. So I will just talk with him after this class. Only he can remain, and rest of you can leave this meeting. I will just talk with him like for 2 to 3 minutes. It's fine. Okay. It's fine.
Sir, but
It's fine.
and of this, we are sorry.
Okay, that's fine. You do not need to worry. Don't worry.
Sorry, sir. We're really embarrassed.
Yeah, that's fine, completely fine. You don't need to be sorry. Again, about your labs and all those things, give your effort. You do not need to achieve a lot of marks or something like that. Just give your effort, and that will be fine. Okay.
Inshallah, sir.
Okay, sir.
I have a question.
Yes.
Sir, where can we practice more problems like you provide us?
Okay. So one of the easiest way to practice this problem, you can check the book for some problems, or you can do one more thing, is write arbitrary statements using the operator that I have shown in a C programming language, then run the code and print out the value. From there you will know the value. Now you try to figure it by yourself, by your hand. Like let's say I want to write something like this. Okay, so I have like I is equal to 50 percentage 24 divided by 3, maybe plus j equal to 3. I'll put a bracket here, maybe percentage k plus plus. I just come up with this on the code, right? And I haven't declared k. Maybe integer k is equal to 6. Something like this. You can write something like this by yourself, and then you can try to figure out the order in which they will be evaluated. You can put some bracket yourself and then fill up the rest of them, or you can just start without bracket. But if you see that it's not compiling, then most probably you have written a wrong statement. Like this one will not compile. Why? Because the other statements have a higher precedence than this one, so the plus cannot be here. This one will be fine, or maybe minus.
Thank you, sir.
Randomly write a statement by yourself and then try to solve it by hand, evaluate by hand, and match with the result of the compiler. Okay.
Understood. Thank you, sir.
Welcome.
Assalamualaikum.
Welcome, assalam. So except the one who accepted his guilt, just rest of you leave the meeting. Welcome, assalam.
Assalamualaikum, sir.
Welcome, assalam.
Assalamualaikum, sir.
Welcome, assalam.
Assalamualaikum, sir.
Welcome, assalam.
Sir, I have a question.
Yes, Tamim.
So, in the previous lab, I have checked the lab tasks of 1A before entering my own lab. So, does that fall under the category of cheating?
No. Is the lab task? Is there any statement in the lab task where it says that you cannot check the lab task of the previous class?
No, sir.
Right, and even if I made 4 lab groups for all the 4 sections, 4 different classrooms, and given the tasks there, would you people not get the tasks from your friends? You would definitely get it.
Yeah.
Yeah, you people would definitely get it. So why would I need to take the extra effort to make like 4 classrooms and try to manage all those 4s, and it will all become just jumbled up? Okay, that's why. You can take a look at the lab tasks of the previous group. However, bluntly submitting tasks with the same name as the previous task or things like that, those will be considered cheating. Some cases happen like that. Okay, that's why I'm saying this. We can definitely take a look at previous last task. So also remember that since 1A faces the task first and 1B, 2A, 2B faces the task second, we can actually judge from a person's course how many have they have solved from the previous lab. It's fine. So people are evaluated accordingly. Anyways, rest of you, please leave the meeting.